Alright, here we go, taking a look at the first practice in the Walch Connect book, so practice 1.1.1. So just a reminder that these videos are meant to help you when you're stuck and to help you understand things better. So use it that way. Try to do this stuff on your own first. Okay, the practice is for you, not for me. So I'm just doing this to give you guys some options so you can check your work and make sure you understand what's going on so you'll be ready for the in-class stuff that we have to go. Okay, so for problems 1 and 2, identify the terms, the coefficients, the constants, oops, wrong color, and the factors of the given expressions. So we take a look at this. Now remember, with terms are made up of numbers and letters, or just letters, right? The variables. So if we look at number 1, terms are usually separated with a operation like plus or minus. So I've got 12a cubed, 16a, and 4. So those are our terms. So I write terms out here. I'm doing it in the wrong color, aren't I? Supposed to match these all up. That's kind of why I underlined them in certain colors. And I seem to forget that. So we got our terms here, which 12a cubed is a term, 16a is a term, and 4 is a term. Now coefficients, remember coefficients are the numbers in front of the variables. So our coefficient would be 12 here and 16. Those are our two coefficients. Our constants, something that is constant doesn't change, so it's the opposite of a variable, and that would be our only number, okay, our 4. So there's our constant. And then our factors. Factors are things that are multiplied together. Okay, a number can be made up of factors. So factors, things that are multiplied together, 12 times a, so factors 12 and a cubed, and then 16 times a, so 16 and a. Those would be our factors. Alright, so we do it for number 2. So if you didn't try this one first, try to do number 2 on your own. Just hit pause, try to do it on your own, and see if you can come up with the right stuff. So hopefully you did that. So our terms here, we've got pluses and minuses separating them. So 21x squared is a term, 3x is a term, negative 15x squared. Now remember that a minus is really like plus and negative. So you could just put 15x squared, but I like to always keep those negatives with them because you need to just have that habit. And then 9 is our 4th term. So we have 4 terms in this one, whereas last time we only had 3. Now our coefficients, so we look for those numbers in front of the variable. So you've got 21, 3, and 15. Now remember, or negative 15. The coefficient isn't the whole term, it's just the number in front. And also remember this idea with coefficients. The coefficient, like 3x, that 3 does not mean, it's not really a number. It's how many x's there are. Remember, repeated addition, the shortcut is multiplication. Here's the multiplication, so we think of 3x is really x plus x plus x. 3 x's added together give us 3 times x. It's that idea of repeated addition, and the shortcut is multiplication. Okay, remember that with the coefficients. Okay, do we have a constant? Yes, we do. It's right here. It's our 9. There's our constant. And then our factors, these are all multiplying because they have coefficients. So 21 with x squared, I believe. No, x cubed. I covered it up. Couldn't see. Nope, it is x squared. Okay. We also have 3 in x, and negative 15 and x squared. Now really, if we're looking at this problem right here, if we really wanted to, you could simplify those x squareds and go 21 minus 15, which would be 6x squared. And then you'd have one less term because you were able to combine those two. And your term would be 6x squared, your factors would be 6 and x squared, and your coefficient would be 6. Okay? So, looking down now. So now, problems 3 and 4 asks us to translate each verbal expression to an algebraic expression and identify the terms, coefficients, and constants of the given expressions. So, once again, we are trying to figure out what's going on here. Okay? So, we've got to take these words and put them into an expression like that. Then we've got to find all the pieces of those expressions. Oh, not the factors though, huh? Okay, so it says half the sum of x and y decreased by 1/3 y. So these are going to be pretty tricky. So it says half the sum. So we want the sum of x and y. So we're doing x plus y. Okay, and we want half of that. So, two ways we could write this. We could add those together and then times them by half. Or we could add those together and divide by 2. Same thing. Okay, same thing. I'll just write it this way though. So half the sum of x and y. So x and y usually means adding them. Okay, with the sum. Half of that, multiplying by a half. And then it's decreased by 1/3 y. And I actually think, to me it sounds like this decreased by 1/3 y. We're going to, decreasing and subtracting 1/3 y would be 1/3 times y, or y over 3. Same idea. The question is, do we put it on the outside of the parentheses or on the inside of the parentheses? But the way I'm reading it, I think we got it right here. The half the sum of x and y, then that is decreased by 1/3 y. So, now, we probably want to simplify this, okay? So, remember, we can multiply these through. So, and an easier way to write it, 1/2 times x is the same as x over 2. So let's just write it x over 2 plus y over 2, because we times them both by 1/2, minus, and then 1/3 y is like y over 3, same thing. Okay, so we can combine those fractions, right? Remember, when we're dealing with fractions like that, we've got to get the common denominators. So 2 and 3 would be 6. So we times this side by 2. We times this side by 3. So we'd get x over 2 plus 3y over 6 minus 2y over 6. So 3 minus 2 would give us 1y over 6, or just y over 6. Okay, so now we need to figure out what the terms, coefficients, and constants are of these. So, we should see that there's no constants, right? That x over 2 and y over 6, okay, that's like 1/2 times x plus 1/6 times y. So they both have variables with them, but those are our two terms, right? 1/2 x, 1/6 y. And our coefficients would then be 1/2 and 1/6. And we have no constants. Alright. Now let's take a look at the next one. So the product of 5 and the cube of x. So product, remember, means multiply. So the product of 5 and the cube of x. A cube, you have just x to the first, x to the second, which is called squared, x to the third, which is called cubed, and then x to the fourth, and so on. You don't really have special names for those. You do, but you don't use them. so we won't worry about them. So the product of 5 and the cube of x, so the cube of x would be x cubed. Okay. The product of 5 and the cube of x would be 5 times x cubed. And it's increased by the difference of 6. So increasing is adding the difference of 6 and x cubed. So it would be 6 minus x cubed. Okay. And we put it in parentheses like that. Okay. Now, we can simplify this one as well because we have 2x cubes. Now this parentheses, there's nothing in front of here, so we can just leave it like this. Remember, when there's no number, that's the ninja 1 there that can appear and disappear. So we've got -1 and we've got 5 for the coefficients. Okay, so here's a good way to think about doing these. If you're still unsure about how to figure these ones out, I'll use some space down here. 5x cubed, remember, there's 5 positive x cubes here. Okay. That's what the 5 means. Now a -1x cubed means we have 1 minus x cubed. Okay? So looking at this, if I have a positive version and a negative version, they're going to cancel each other out, and we're only going to have 4 of them, so it would be 4x cubed. And then we didn't deal with the 6, so just plus 6. The other way to think about it is take your coefficients, 5 minus 1 gives us a positive 4. Okay? So same concept, just trying to give you some simplified, maybe, ways of thinking about it. Alright, so we have terms. We've got 2 terms, right? We've got 4x cubed and 6. And that's not a b, that's a 6. Okay, those are our terms. We also have one coefficient, the 4. Okay, 6 doesn't have a variable, so it's not a coefficient. It makes it a constant. Okay, now question 5 says, write an expression with 4 terms containing the coefficients 3, 6, and 9. Okay, so we need 4 different terms. So we can have a constant for a term. Okay, we can have an x. Okay, we don't like to have 2 terms with the same x because we like to simplify them. So we'd probably want an x squared. That gives us 1, 2, 3, and then an x cubed. Now, the coefficients are 3, 6, and 9, so our constant can't be any of those. They have to match up to those. So you don't have to put them in any particular order, though we usually start with the highest power. And then whichever number, easiest would probably be take the 3x cubed. Then maybe we'd subtract a 6, x squared, then maybe add a 9x, and then maybe add, well, let's subtract 15. Okay, do we have 4 terms? 1, 2, 3, 4. Do we have our coefficients 3, 6, and 9? Yes, we do. So that's a possibility. You could have some aspects that are different, and that's fine too. But there we go. So that was our front page. Now let's take a look at the second page here. Okay, so now we got a bunch of story problems here. Now it wants us to write an algebraic expression. Okay, we've been doing that, haven't we? Remember, it's not an equation. An equation has an equal sign. An expression has terms. Sometimes it'll have factors, coefficients, and constants, and it'll be adding and subtracting, multiplying, dividing them. Okay, but it's different than an equation because there's no equal sign. So let's take a look at what we've got here. So number 6, Gavin agrees to buy a 6-month package deal of monthly gym passes, and in turn receives a 15% discount. Write an algebraic expression to represent the total cost of the monthly passes with the discount, if x represents the cost of each monthly pass. So we've got a variable, and x represents the cost of each monthly pass. Okay, so he's got a 15% discount. And he's got 6 of them because it's a 6-month for a monthly pass each. Okay, so if x is the cost of each pass, he's got 6 of these, right? To get the total cost, we'd add them all up. or we'd shortcut write it and just go 6 times x, correct? But he's receiving a 15% discount on those. So we've got to subtract a 15% discount on each one of these. Okay? Well, how would we find that discount? Well, whenever you take a discount, you take that total cost and then you would, multiply it by the percent in decimal form. So you go 0.15 times x. Okay, now we're going to do that 6 times, right? So we'd essentially say, 0.15 times 6x. So you'd probably want to get out a calculator and go 6 times 0.15. Let me grab out my calculator to see what we got. So that would end up at 0.9x. So 6 minus 0.9x would give us 5.1x. So this could be our expression, and we could leave it like that. We could do it this way. We could also think another way. Okay, we could say, you know what? So if we got a 15% discount, the full price would be 100%. If we subtract 15% of that, we've got 85%. So we could go 0.85 times 6x. And if we did that, that would get us to that same number. And that's just a different way of thinking of it. This is total cost minus what our discount saved. This one is just thinking about what we saved, or what we paid after the 15% discount. Alright, now let's take a look at number 7. Clear it up a bit here. So, Andre purchased 10 cans of tennis balls from an online store and received a 25% discount. Shipping cost $5.99. Write an algebraic expression to represent the total cost of the tennis balls with the shipping cost, if x represents the cost of each can. Okay, so kind of similar to number 6, right? And if we remember number 6, we ended up with either versions of this, okay? So, but this time we're adding in something, right? We are adding in the purchase, or the shipping cost. Okay, so shipping cost isn't going to change here, right? That's a constant. So we know it's not going to have a variable next to it. It's just going to be $5.99. Okay? Then we have x represents the cost of each can, and we've got 10 of those. So normally we'd go 10 times the cost to get our total cost, right? The difference is we're applying that 25% discount, okay, of the cost of each can. Okay, so we'd be subtracting that 25% of the total cost of those. Okay, then we'd be adding that shipping cost to it, right? And that would give us our answer. Okay, so we can simplify this a bit, right? 0.25 times 10 would give us, if you typed into your calculator, that would give you 2.5x plus 5.99, and we're subtracting that from 10x. So 10 minus 2.5 would give us 7.5x plus 5.99, and that would be our simplified version of the expression. Okay. Remember, the other way to do that would be to multiply the original by 0.75, which would give us our same answer. Okay, if we're thinking about it differently. All right. Now we need to make sure we've got the terms, factors, coefficients, and constants. So our terms, we've got two terms, 7.5x and 5.99. So those are our two terms. Okay. Our factors, we've only got one, and that would be the 7.5 times x. Okay. Those would be our factors. 7.5 would also be our coefficient, because it's with the variable, making 5.99 be our constant, because that one's not changing. Alright, so let's look at number 8 now. Okay, Nadia and some friends went to a movie. Their total cost was $30.24, which included taxes of $2.24. Write an algebraic expression to represent the price of each movie ticket, not including taxes. Let x represent the number of Nadia's friends that went to the movies. Alright, so let's think of each part here. So first idea, their total was $30.24. Tax was $2.24. Okay, and that wasn't figured into the 30. So we want to remove the taxes. Okay, so first thing we'd have to do would be to subtract, right? That would get us that cost, but we don't want it yet. Okay, then we want x to represent Nadia's friends. Well, Nadia also went, so her friends plus Nadia would give us the total amount of people that went. And usually the way you split something is they would have all got the same type of movie ticket, so we'd have to divide them together. So it would look something like this. 30.24 minus 2.24, that would give us the cost minus taxes over the number of people we have. Okay, now we simplify what we can simplify. So 30.24, do it in a calculator or do it by hand. Okay, 4 would be 0, 2 would be 0, 30 minus 2 would be 28, so it would be $28 over x plus 1. Okay, now we look at this. Some of you might want to say we've got 3 terms. We've got this, and this, and this. But we actually don't. Because that x plus 1 is on the bottom of a fraction, that whole thing is our term. That's it. That expression is just one term. So there's our term. Okay, so our factors would be, if we could kind of split this, up. If you go 28 times 1 over x plus 1. That's kind of the same thing. And this is kind of a stretch to do it this way. But that would make 28 a coefficient. It would also make 28 and 1 over x plus 1 factors. Okay, and we don't have any constants. So I don't really like splitting it up like that. I honestly would leave it like this and just use that one. Okay, but to find the coefficient and the factors, we would have to split them up. But I prefer it this way, and then just saying we've got one term and going from there. Alright, number 9. Okay, so number 9. The area of a trapezoid can be found by multiplying the height of the trapezoid by half of the sum of base 1 and base 2. Now you see those little crazy 1s and 2s? Okay, when we're dealing with those are called subsets. That doesn't sound right to me. I just paused and checked it up. It's called subscript. I knew it was something like that, something subby. Okay, so those are subscripts. So that basically means we would call both of those bases b. The variable would be b. So for the first base, we just go b sub 1. And for the second base, b sub 2. Okay? Because when we've got a trapezoid, remember the shape, here's where a picture can help us understand. You've got the two bases here. So they call one and the other one 2. Okay? So then our height would be this distance. Okay? So it says the area of a trapezoid can be found by multiplying the height. So we've got height times something by half of the sum of base 1 and base 2. So base 1 and base 2, we're adding them. So we'd have base 1 plus base 2. And then we are taking half of that. So we could write it 1/2 like that, or you could even write it like this. Okay, I believe in the formula version of it, they usually put the 1/2 in front. And we're timesing all that by the height. So something like this. Okay. though I think in the formula version of it they put the h on the back. Okay. So now, can we simplify that at all? Yeah, we could multiply, we could distribute this 1/2 h and times it by b1 plus, and then distribute it in by the b2. Okay, that's probably what I do for this purpose. So, we've got two terms, right? One term, two terms. Do we have coefficients? Yes, 1/2 on both of them is the coefficient. Okay. Do we have factors? Yeah. 1/2 h and b1, 1/2 h and b2. Okay, those would be the factors. Do we have any constants? No, because we've got variables involved in all of it. Alright, so there we go for that one. So, last one here. The surface area of a cylinder. Okay, so remember, here's a cylinder. Okay, so remember, surface area is if we were going to wrap that. Okay? So if we're wrapping that, we've got the top circle, the bottom circle, and then we'd have the rectangular piece that ties them together that would be wrapped around. So those, we're finding the areas of all three of those. Whereas volume, remember, is how much something is inside of it, how much something fits inside. So we don't want what's inside, we want around the edge. Okay? So it says the surface area of a cylinder with a radius r, so radius would be of the circle, and a height h, that would be height, is twice the product being multiplying, of pi and the square of the radius, plus twice the product of pi, the radius, and the height. Okay? So there's two things that we're dealing with here. Okay? And it has to go based off this idea. Okay? The area of a circle is pi r squared. Okay? We've got two circles. So we've got 2 pi r squareds. Okay? That's where twice. Okay? And that's the product. So those two would be together, would be 2 times pi times r squared. Okay? Plus twice the product of pi, the radius, and the height. Okay, now that has to deal with thinking about this part, the rectangular part. Because in a cylinder, and let me clear some space, in a cylinder, as we unwrap that, that would give us a long rectangle. Now the top's length would be the length around the circle, which is called circumference. Okay? Which is 2 times pi times the radius, 2 pi r. Okay? And then the height makes up the other side. Well, how do we multiply and find the area of a rectangle? Base times height. So we get 2 times pi times r times h. So that represents the rectangular piece. Those represent the circular pieces for the surface area. Okay? And could you simplify this? There's a few things you could do, but not in the way that would make it much easier. So, do we have any constants? No, because we got variables in each term. We've got two terms, one term, two terms. Do we have coefficients? Yes, 2's are the coefficients. Do we have factors? Yes. Okay, 2 times pi times r squared is one factor. 2 times pi times r times h are the other factors in the second term. So, there we go. Ended up taking a little bit more time than I thought. These were some pretty difficult story problems to go along here, but that's how we do it.